Now we're going to talk about light energy. What we need to know about light energy is light always travels in a straight line. And the reason that we know this is because we can see the stars at night. So light travels in a straight line. If it did not travel in a straight line, we would not see the stars. Because what happens is the stars are bright in the night sky, and here we are on Earth, wishing upon a star, and the light from the star travels in a straight line and reaches the Earth. And that's why we can see it with our eyes. Okay, so light travels in a straight line. And there's three ways in which we need to talk about it behaving. Okay, the first way that light behaves is that it reflects. And light reflects by bouncing off of objects. And the types of things that light reflects from are shiny surfaces and light-colored surfaces. Okay, so light bounces off. That's what reflects is. Reflects, bounces off shiny or light-colored surfaces. Okay, and just like in class, we used a mirror and a white piece of paper to demonstrate this. Surfaces, sorry. Okay, so let's pretend this is our shiny or our light surface. And we used a flashlight, if you remember, and we shone the flashlight directly onto the surface of a mirror and directly onto the surface of a white piece of paper. So it can be shiny or a light surface. And the light comes in a straight line, and what happens is it bounces off. And if you remember, Mrs. Colicia shone the light on the mirror, and then she shone it into different people's faces, and we showed how bright the light was after reflecting off of the shiny or the light surface. So don't forget, one way in which light behaves is that it reflects when it hits a shiny or a light surface. So those are the requirements. It has to have a shiny or a light surface in order to reflect. The next word that we need to know and the next behavior of light, similar to reflect, but don't get them mixed up, it's refraction. Okay, and refraction is when light bends as it goes through a clear object. And one of the ways that we demonstrated this was use a prism. And when we shone the light through the prism, remember it was a triangular prism, and we used our flashlight again. Such a great artist. So here comes our light traveling in a straight line, and as soon as it hit the prism, if you remember, we had a rainbow of light. And if you recall, what I told you is that the white light that came in gets bent and it separates into its color wavelength of red, orange, yellow, green, blue, and violet. And that's why we saw the beautiful rainbow on the ceiling and on the floor, because the light bent and it refracted or fractionated into its component wavelengths. And if you think about the word refraction, okay, these wavelengths are fractions of this wavelength. So we take the whole and we split it into parts. And that's a good way to remember that refraction is bending the light into its component wavelengths. Another way that we demonstrated refraction was when we took a cup or a beaker, if you recall, and I put some water in it, and then I put a pen in it. And the pen actually looked like it was broken, because what happens is the light hits the water, and your eye actually, I'm just such a great artist. Here's your eye. Your eye sees the pen as bent or broken because the light that hits your eye actually is bent. So the light goes through the water and then it's bent. And when the light hits your eye after it's bent, it shows that the pencil is broken. So what you need to know is refraction is when light bends. Refract is the same thing as bending. Okay, and the third one that we talked about was absorption. And light absorbs let's put absorption. Okay, and light, when it hits a dark surface, will absorb. And if you recall, when I shone the light, the flashlight on to a dark surface, it was a black piece of paper if you remember in class, okay, and we call it a dark surface. The light comes in from the flashlight, and it doesn't bounce off. It may bounce off a little bit, but it mostly absorbs into the paper. So we'll get a tiny little bit of reflection, but not very much, because the nature of light is that when it hits a dark surface, it absorbs or stays in. And if you think about a sponge, many of you guys have sponges at home in your kitchen sink, and when you put a sponge on top of some water, what happens is the water goes into the sponge absorbs the water, and the water does not come out. Same type of thing as with light. Light goes into the dark paper and does not come out. And that's what is called light absorption.